afternoon, good morning, whatever time you're watching this, but welcome to lesson 9.5. Today we're going to be talking about, let me turn the page, hold on. Today we're going to be talking about finding unknown angle measurements. Our learning target is to use facts about angle relationships to find unknown angle measures. Our success criteria can be measured by our ability to identify adjacent, complementary, supplementary, and vertical angles, our ability to use equations to find unknown angle measures, and our ability to find unknown angle measures in real life situations. Let's start by looking at the key ideas. Our key ideas are two angles are adjacent angles when they share a common side and have the same vertex. So when we're looking at angles, if we have two different angles, but they share a common side, so in this instance, this one right here, this is the common side that they're sharing, and they have the same vertex. The vertex is the point where two lines meet, so they share this vertex right here. You can see that. Then they are adjacent angles. Okay? Complementary angles, let me delete this. Complementary angles are angles whose the sum of their measure is 90 degrees. So when we're working with a 90-degree angle, typically we have that little square in the corner that tells us this is a 90-degree angle. And this 90-degree angle will be bisected by another common side, by a side. And together, the two angles that make up that 90-degree angle are complementary, which means they equal 90 degrees. Okay, so that's what that one means. Supplementary angles are angles who the sum of their measure is 180 degrees. So we're talking about, angles like this. So this one and this one that equal 180 degrees. Maybe angles like this, where this one and this one equal 180 degrees. We can even have them going vertical. So for instance, they could be, that, and so this one and this one would be supplementary angles, but they equal 180 degrees. Either way they go, anyway, it doesn't matter. They equal 180 degrees. Okay. The last one we're going to look at is we're going to look at vertical angles. And vertical angles are probably the most difficult to explain and for you to understand. Two angles are vertical when they're opposite angles formed by two intersecting lines. So we're going to have two lines. They're going to intersect, and we're going to look at the angles that are opposite of each other. So this angle and this angle are vertical angles, and this angle and this angle are vertical angles. Vertical angles have the same measure because they're both supplementary to the same angle. So what that means is that the green one right here plus this red one right here, they equal 180 degrees. And if you look, you'll notice that this green one plus that same red angle, I can't do it this way, equal 180 degrees. That means they share this angle right here and this angle right here. They're opposite, and they share this angle right here. Vertical angles also cannot be adjacent. They are not adjacent. That means they do not intersect each other. They don't, like, this is adjacent. Vertical angles are not adjacent. Okay? So that's why I said that vertical angles are probably the most difficult to understand, just because there's a lot of information that goes into what makes up a vertical angle. Okay? Let's go ahead and look at example 1. And example 1 wants us to name certain things. So let's start with A. For A, it wants us to name the adjacent angles. Now, there are several sets of adjacent angles in here, and I would accept a multitude of different answers. The answer the book gives is angle ABC and angle ABF. So let's go ahead and look at angle ABC is right here, and angle ABF is right here. And you can see that they're adjacent. They share this common side right here of AB, okay? And they share the vertex right here that's formed by angle B. So that's why you'll notice that B is in the middle of both of them, because B is the shared vertex. And that's that same vertex that we're looking for right there. Angle B, for B, it asks for complementary angles. Remember, complementary means that they equal 90 degrees. So we're looking for the ones, we're looking for that square. We see that square right here. So that means that for B, our complementary angles are angle EBD and angle CBD. Noticing again that they share that vertex of B, okay? And they're the two angles, EBD and CBD, that have that make up that 90-degree angle right there. Okay, C asks us to find supplementary angles. Supplementary makes straight lines. So when I'm looking at this, I see two different straight lines. I see this straight line right here, and I see this one right here. The book has us looking at the vertical straight line, this one right here. So we're going to look at the angles that make up that straight line. So the first one I see is angle ABC, which is right here, angle ABC. And then the second one is angle DBC right there, and angle DBC. Those two angles, when you add them together, equal that nice straight line right there. Okay, the last thing that it asks us to find is a set of vertical angles. Now, there are several different vertical angles in here, but the ones that we're going to look at are right here and right here. They're opposite of each other. They're formed by this line that intersects with this line, and they share that same angle that makes them supplementary. So the first one that we're going to look at is angle ABF. So ABF right here, ABF. And the one that is vertical to that is going to be CBD. Right here, CBD. And they're the angles that are opposite of each other, okay? So those are vertical angles. So what I want you to do now is I want you to go ahead and pause and do the try it. And when you come back, I will list out the answers for the try it, which asks you to identify the adjacent, complementary, supplementary, and vertical angles of this drawing located right here. Okay, so hopefully you paused and you came back. Let's look at the set of adjacent angles in this one. In A, we have a set of adjacent angles at angle QJK and angle KJL. So QJK right there and KJL right there. They're adjacent, they share a common side right here, and they share a vertex right there at J. Notice that J is in the middle of both of them. Okay, B asks us to find the complementary angles, so we're going to look for that right angle. I see the right angle right here. So we're going to have angle PJN. Oh, I wrote angle twice. Hold on. Angle PJN and angle NJM. JM. Okay, so PJN and NJM right there. Again, common vertex at J. All right, C asks us to find the supplementary angles. Again, when I'm looking at this, I see two different, actually on this one, I see three different straight lines, which means we're going to have three sets of supplementary angles. I'm going to go with the one that the book has, which for C is angle QJK. So QJK is right here. And then we're also going to go with KJM. So KJM right there, and you can see that together they form that straight line. Okay, and now let's go with D, which asks us to find a set of vertical angles. For D, we're going to go with angle LJM. So LJM right here. And then angle P, or I'm sorry, they start with Q. It doesn't matter. I'm going to say an angle PJQ. It can also be QJP. It doesn't matter. What matters? We have that J in the middle. It's this one right here. And you notice they're opposites of each other. Okay, so that was the try it for that one. Let's go ahead and go on to example 2. In example 2, they're asking us to use pairs of angles, and we're going to classify different sets of angles, and then we're going to identify the value or find the value of x. So this is where we're going to use different angle measurements to find x. Now, in A, notice they're opposites of each other, right? They're on opposite sides of each other. And they share that same supplementary angle. So in A, they are vertical angles. And the value of x, vertical angles are congruent. So the value of x here is 70. I don't know why I wrote 90. Hold on. Paying attention. It's 70 degrees, okay? Because they're the same right here. They're vertical. They're the same. So that means that this x has the same value as the one that's vertical to it. In B, they form a right angle. We see that right triangle telling me right there. So these are complementary. Oops. Complementary. And so we can use that. We know that complementary angles, they equal 90 degrees. So I can add these two angles together. So I can do 31 plus x plus 4, okay? I can use my commutative property to kind of rearrange these, or I can just combine like terms. So I get that 90 is equal to 35 plus x. Subtract 35 from both sides, and I get that x equals 55. Now I could use that to find the measure right here. I could say x plus 50, x is 55, 55 plus 4 is going to be 59, 59 plus 61, guess what? Plus 31, I don't know why I wrote 31 equals 90 degrees. So that's kind of my little check right there, okay? So there again, we used what we knew about angle relationships to find the measure of a missing value. We used it both to find the measure of x, and then I showed you how to take that a step further and use x to find the actual measure of the angle. Okay, let me delete these little things here. And then, I don't know why this one won't delete. Oh, there we go. Okay. And now let's go ahead and look at C. In C, they form a straight line. We see this straight line right here. They form a straight line. The measure of a straight line is 180 degrees. So these angles are supplementary. And so that means that x plus x minus 4 is equal to 180. So this is the x, this is the x minus 4. I'm just adding them together because I know that together they equal 180 degrees. Combine my like terms, I get 2x minus 4 equals 180. Add 4 to both sides. 2x equals 184. X equals 92. Okay? So I found the value of x. That's all they asked me to do. Identify the angle relationship and then find the value of x. I did that. So now I want you to go ahead and I want you to do try it 2, 3, and 4. Pause the video, do 2, 3, and 4, and then when you come back, I'll leave you the answers on here. In the meantime, while you're paused, I guess it won't be while you're paused because even when you come back, I'll still be in the same spot. I'm going to try to delete these giant things that I put on here. There we go. There's one down, one to go. I don't know where to click to delete it. Sometimes it lets me click right on it. I don't know. We might just leave that one. All right, let's look at 2. In 2, the angles are supplementary. They form a straight line, so they are supplementary. And the measure of x is equal to 95 degrees. Okay. In 3, they're vertical. They're opposite from each other. And so x is equal to 90. In 4, they're complementary. Okay, they add up to 90 degrees, and the measure of x in number 4 is 31. Okay, if you have any questions about those, you can email me, you can Google chat me, you can meet me tomorrow in the Zoom meeting, or maybe it's today and you're watching this. However you need to get a hold of me, you can do that to ask me how to go over these triads, okay? Oh, you can see I've already been working these out a little bit, so that's what this writing is here. Just ignore it for a minute. I apparently didn't erase it when I was working these out for myself earlier. All right, erase now. So let's go ahead and look at example 3. In example 3, we have a lot of missing information in example 3. So in example 3, we're going to use everything that we know. And one thing I want to point out is this little remember box right here, where it says, remember that the sum of the measures of the angles around a point is equal to 360 degrees. That means if I add up all of these angles right here, they equal 360 degrees, because look at that. They formed a circle. So the measure of the distance of all the angles around a point is equal to 360 because they form a circle. Okay. So if it wants us to find the measure of EAB, let's identify EAB right here and wants us to find the measure of that angle. Luckily for us, we know this angle right here is 90 degrees, okay? We just have to find this piece right here. So we have to find BAC. We have to find BAC right there, okay? Now, something that I know, let's erase some of this. I know that these two angles right here equal 180 degrees. They form a straight line. So that means that 4x plus 8x plus 12 equals 180. 12x plus 12 equals 180. 12x equals, what's 180 minus? So 12x equals 168. X equals 14. Okay? And that's just, I subtracted 12 from both sides, and then I divided both sides by 12, and I got the x equals 14. So x equals 14. I'm going to write that right there because I'm going to have to erase all of this because I don't have enough room to write. So now I know that x equaled 14. That's great to know that x equals 14, but it still doesn't tell me what this angle right here is, what angle EAC is, or BAC. So what I'm going to have to do is I'm going to have to plug 8 times 14 plus 12. Okay? So all I did was I plugged 14 in for x right there, so I can find the measure of that BAC angle. Now, 8 times 14 is going to be 112. Okay? Plus 12 is going to be 124. So that means that angle BAC equals 124 degrees. Now remember, all the way around equals 360 because it forms a nice circle. So I know that this one right here, BAC, is 124. I know that this one right here is 90. and I'm looking, this is my question mark. This is what I need to find. So I'm going to say that that's x, and I know that all together they equal 360 degrees. Okay? So 124 plus 90 is going to be 214 plus x equals 360. Subtract 214 from both sides, and we get that x is equal to 146 degrees. So that means all of that, we did all that work just to find the measure right here. Oh, let me delete that part. Hold on. We wanted to find the measure right here of angle EAC. So we found the measure of angle EAC is equal to 146 degrees. Okay? That's that. So now what I want you to do is I want you to go ahead and pause, and I want you to use what we just did to find the measure of the missing angle in the triad. I'm going to delete all this stuff. It's going to take me a minute. I wish there was an easier way to do this, but there's not. So we're just going to go delete, 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 delete. Okay, now let's look at the triad. Let's look at triad number 5. It wanted us to find NJM. Okay, the measure of NJM is going to be 60 degrees. Okay. For number 6, they wanted us to find KJP. That's a big angle. That's 150 degrees. And for number 7, they wanted us to find KJM. KJM is going to be 120 degrees. Okay? I will be happy to work any of those out for you. If you have any questions, just let me know, and we can work those out on Zoom. If you didn't get those right, go back and try them again. See if you can find them. Pause the video, rewind the video, go back and try them again, and see if you can figure out how to get to those measurements that I just put on there. Okay, example 4 says, a city worker designs an intersection of 3 roads that will be constructed next year. The measure of the angle between any 2 roads must be at least 60 degrees in order for the vehicles to turn safely. Does the design shown meet the requirement? So we need to look. We have one angle right here. We know that GAF, if we can see GAF right here, GAF equals 60 degrees. Okay? And so we know that DAC right here is vertical to that, so it also equals 60 degrees. Okay? Now, BAC, I'm going to erase on here. BAC and DAC and EAD, these ones right here, these 3 right here, add up to this straight line right here. So that means that those 3 angles add up to 180 degrees. Okay? So we know that 9x, BAC is 9x. We know that DAC is 60. And we know that 6x plus 15, which makes up that last angle right here, we know that together those equal 180 degrees. We're going to use this. We're going to find x. And once we find x, we're going to be able to find the measure of this degree right here. Okay? Or this one right here even. Okay? So let's combine like terms. I have 9x and 6x. That gives me 15x. And I have 60 and 15. That gives me 75. They equal 180. Plus, come on, Miss Crewy. They equal 180. So then 15x equals 105. Divide, and we get that x is equal to 7. X is equal to 7, so now we're going to plug that in, and we're going to find the measure of EAD or DAE right here, which is 6x plus 15. So I'm going to write a little note right here, x equals 7. I'm going to do some erasing. Okay. Let me delete these. I kind of wish I might undo the thing where it snaps the shapes. Okay, so if x equals 7, then let's figure out what 6x plus 15 is. Okay, so 6 times 7, all I'm doing is substituting. 6 times 7 is 42 plus 15. 42 plus 15 is 57. Now remember, so that means that this angle right here, that means that angle EAD is 57 degrees. 57 degrees is not 60. 57 is less than 60, so this design does not meet the requirement. Remember, for a requirement, they had to be at least 60 degrees. Because this angle, EAD, is only 57 degrees, it doesn't meet the requirement. And we just use math to solve that. Pretty cool stuff. That is all I have for you. So you can go ahead and you can find your assignment in Big Ideas. I wish you the very best of luck, and let me know if you have any questions at all.